responsible for QA automation in web in the company which is called Wargaming. We produce online games which require actually a lot of web services. And today I'm going to share our experience and in page objects pattern implementation in Python. By the way, does anyone use Python? Don't show. Nice, target audience. So I'll start from short prehistory. 2 years ago, all automation stuff in Wargaming was done in Java. At the same moment, product development mostly used Python stack. It was strange and inconvenient because, you can't talk to developers using the same language. You can't use their expertise and their experience. On the other hand, developers can't help you with test development stuff. So, hopefully, we had opportunities to fix this issue. There were a lot of new projects. We didn't have a too huge test automation coverage, so we switched to Python. And when it came to end-to-end tests through UI, we wanted to reuse one of the best practices, page objects. So there are a number of implementations. There are a lot of articles. There are a lot of talks related to implementations in Java. Like, for example, I personally have worked a lot with Java before Wargaming. There are good implementations available as libraries in open source, for example, HTML elements from the guys from Yandex. So, as for Python, we really couldn't find any suitable solution which would fit to our needs, and being inspired by HTML elements, decided to make sort of port in Python. And our requirements were the following. First of all, we would like to have API which closely complies with original WebDriver API. We wanted just to extend Webium class, for example. We didn't want to use any wrappers, things like that. Also, when describing pages, we would like to have an option to define a single element as well as range of elements. And there was a need in supporting a sort of nested structure for pages. We wanted to have support for footers, headers, sections, blocks, and any containers so that elements at any level could provide search for their children. And also, it is convenient to resolve your actual element only once you access any attribute of the page field. Only at that moment. It's so-called lazy initialization. It's one of the requirements we had. But before reinventing the wheel, of course, we consider use some alternatives, a number of alternatives. Let's review some of them. There are page objects in robot framework. It's popular enough in Python stack. What we didn't like in this framework, first of all, it's how pages are described, actually. First of all, locators are stored in a dictionary structure. And moreover, Selenium RC notation is used in order to describe locators. Secondly, there's no any explicit classification for UI elements. You cannot extend any object with some custom behavior. And you have basically, there is a sort of base dictionary API. There are dictionary of selectors. There are a set of functions, and that's it. Another alternative was Chromium core, which was actually close to what we were looking for. Chromium core supports element customization, but its model of declaring pages and the way you initialize elements, they are not so obvious. For example, there is support. It has own alternative system of classes, which sometimes duplicates WebDriver API. For example, you can see that there is a constants for locators. There are the same constants in WebDriver API. So it's strange, at least. So Chromium's core API didn't look intuitive for us. On the other hand, we would like to have some simple, explicit, intuitive way to describe pages. One of the best alternatives for the page object implementation was from WTFrameup. It's a web testing framework. Don't get it wrong. In order to describe your pages, you just add some class attributes, which are actually lambda expressions. Lambda expressions contain a way you get an actual element. It's simple, and it is nice. But lambda expressions may be too long, and it leads to unreadable code, things like that. Also, this concept does not assume using any nested structures, any containers. What about Webium? So, Webium, Selenium, Appium, Chromium, at least we are in the trend. Now, ending, it is supported. But seriously, it can be considered as HTML element support in Python. However, implementation relies on features that are very specific to Python. And this fact, of course, adds certain differences into the approach. Let's look at what we have. As usually, there is a base page class. The alternative frameworks contain this class as well. It's standard feature. We extend base page and specify the page address by passing it into the base page constructor. We also can specify WebDriver instance if you want, but if you don't want to care of it, Webium will do it for you according to specified settings. UI elements are described using special structure, the find. Right? This name is derived from Java implementation. Basically, by using find, you describe how the page looks like. You just say, there's a Google page, it has certain elements with some names. So here, find and base page are from Webium. The rest is from Selenium API. Find statement describes how to search for an actual element on UI. You specify search strategy, search expression, and if it is required, a type of element. If you do not pass type of element, it will return WebElement instance by default. The point here is that Webium starts looking for an actual element only once you access any attribute of the page field. Only at that time. And this behavior, by the way, is implemented using descriptors mechanism in Python. This is advanced but powerful feature. It's actually easier than monades in functional languages, but it's a little bit complex. So Once you have described your page class, you create page object and use its attributes. And the matter is that an instance of web element is returned and created only once you, for example, call thinKeys, click methods. Or, for example, when you access the value property. So this is a simple example, but it explains the principle. In practice, many elements we work with have some custom behavior, but web element class provides a generic interface. It's great. It must be so, because it is API, it should be abstract. But in any case, you intend to reuse your code. For example, every time you describe some logic how to get text from some input. You combine some basic API calls into more complex action, and so on. In order to add extra behavior to your elements in Webium, you declare a new class which extends web element and adds some, or override, some extra attributes, method or properties. And then you just need to pass your custom class to find at the first argument. That's it. And the usage is the same. You create a page object which has some custom behavior, some custom fields. So, and once you access the text property of the text field, the instance of custom class is returned instead of web element class. So, finds, there's another statement. Finds is used in the same way as it's done for find, but instead of a single element, it returns a list of elements. So in the example, in the current slide, we print a number of search results from the page. So finds also supports a various type of custom controls. For instance, instead of list of web elements, we can return list of links that have some extra fields or properties. And by the way, Webium includes some most frequently used controls in the Webium settings module. You can use it. Now let's extend our example with the search result page. Instead of list of links, we will return a list of containers. Each container include here link, page address, and some preview text. First of all, let's define a new element class which will be a class for our containers. And this class includes fields we need. In Webium, container classes are subclasses of web element also. And nested elements are defined in the same way as is done for page objects. We use find statement again. However, locators are specified according to search context. They are relative to the container. Once we have our container class defined, we pass it into finds, the first argument. And in the example, as you can see, in order to access any nested elements, just dot notation is used. One more type of containers that is supported is called logical container. I wouldn't say we have used them much, but in some cases they may be useful. For example, they can be used once you need to group some elements, but you do not want to change search context. For example, you still would like to search in the root of the page. One more example. You have page header, which contains some links with unique locators. And in this case, you do not have to search for the container first. You can search for links directly. So, logical container class is not subclass of WebElement, since it doesn't support search context. But the way you define logical container remains the same, unless you don't pass any locator details, because there's no search context. They may be useful. Everyone who has ever written UI tests has met this verification. At the first glance, it looks like a standard check. You do something, and you like to verify that some element is present. On the other hand, it is not so trivial to implement the check. There is a link with proofs on the slide. And folks, especially who are new to automation, continue to reinvent the wheel in their tests and frameworks. We have included this verification in Webium. Let's look at how to use it. Every page and any container contains include this ElementPresent function. So it takes an element name, and that's it. This function is called only on page objects or on containers. UI elements do not have this method, because once you are trying to call any of methods for page field, you anyway trying to get this element. And if it is not present, you will receive an exception, which is part of check. It doesn't make sense. And here's an example. There's a fake element which is not present. When we called ElementPresent for this element, we receive false. So by default, this method checks that element exists and it is visible. But if visibility is not critical, we can skip this check by passing true for just in DOM parameter. Also, you can pass timeout, and the function will wait for successful results for specified time. It won't throw any exception in case element is not found. It just returns false. So sometimes we cannot use static locators because some part of locators is actually unknown in advance. Here's the example. There's a list of news links on the home page. Once you click on one of the links, a new page is open, and the title, the news title, depends on the link we clicked before. And let's assume we don't have any information regarding the titles. We don't know them in advance. In order to handle this case, dynamic pages or parameterized pages are used. These are usual pages, but the way you define elements is a bit different. The fields are defined in the page constructor. All variable parts are passed into init method. And since the scope of fields changes from class to instance, you have to specify search context explicitly. Find has context parameter for this purpose. And in our case, in the slide, it's just current object, current page. It's self keyword in Python. In the example here, click first news method of home page return a new page object which already has all defined locators. So one more obstacle which you may run into when developing UI tests is dynamic content. Things like AJAX and so on. So I think sleep statement is in the past. So however, recently I saw people use some loops with sleep statement. Don't use it. First of all, standards Selenium bindings include proper structure, such WebDriver weight, and so on. You can use it. In our case, we use Python library which is called waiting. It contains wait function. We created a wrapper for wait function and included it in Webium. The difference is that our wrapper handles any WebDriver exception. Actually, ignoring two generic exceptions is not correct way in Java, for example, but in most of cases is it what you need. You of course will get less detailed log, but the test scripts will work more stable. So, and the last line in listings is example of wait usage. You pass a function of the condition, some message to print after timeout is expired. That's it. And eventually settings. So you can tune Webium. Key parameters are stored in Webium.settings package. You can change default timeout for wait function, for example. Also, there is an ability to specify default locator type. For example, you decide to use only CSS locators on your project. You set this parameter, and you don't have to pass search strategy into find calls, basically. So for debug purposes, all settings can be overridden by adding local Webium settings module. It's common way in Python stack. Implicit wait is enabled by default in Webium, and it takes 30 seconds. It can be configured. And please take into account, it means that once you access any attribute of the page field and an actual element is not present, it can take up to 30 seconds before you'll get an exception. But in most of cases, it helps a lot. So on the other hand, implicit wait is disabled for finds structure, because by default WebDriver waits for at least one element is available on the page. It's default behavior in WebDriver API. So what we expect, we'll get an empty list immediately. I don't know, probably it wouldn't make sense to do it in the same way as done with WebDriver API by default, but that's all. And last but not least, actually it's up to you how you create a WebDriver instance. So Webium only provides a way to describe pages. There is a driver class parameter which actually represents a class or a function which should return your instance of WebDriver. Also, you can specify a WebDriver instance for each page individually by passing it into base page constructor. So it's pretty flexible. By default, Firefox instance is created. It's default behavior. And if you use nose in order to run your tests in Python, there is a plugin for closing browsers after every test or after a suite of tests. And that's it. Here are the links to documentation and sources, also contacts of developers. It's me and Igor Horol. We'll appreciate your feedback and feel free to send your pull requests. Thank you. Questions?